Good evening, friends. Now we are going to move towards the last chapter, that is the heat transfer to fluids with phase change. Up till now, I will just take the brief review regarding the with phase and without phase change. So basically, the heat transfer in case of with phase change is really very critical to understand because the heat is going to associate with what are the phase change. So it is a complex process and it is very difficult to identify the quantities of the rate of heat flow or heat transfer, which is influenced by the rate of nucleation of the bubbles, drops or crystals, and by the behavior of the new phases after it is formed. Now this chapter is dealing with the condensation of vapors and boiling of liquids. Basically crystallization is also comes under this chapter, but it has been covered in mass transfer, so later on you can learn about it. So transfer from condensing vapors is the first subtitle or subtopic for us, where the phase change means it is very simple, due to heat giving or heat taking, the phase transfer takes place. So there are two types of condensation of the any mixture or any solvent. So there are two types. One is the film wise condensation, and another is drop wise condensation. So basically the drop wise condensation is always accepted or expected because the rate of heat flow, the rate of heat transfer is always greater in case of the drop wise condensation. So I will give a simple practical example where uh, whenever in rainy season you might observe the water which is coming from the slab or ceiling, it is getting leakaged. What happened, at that time number of droplets are formed, and whenever more than one or two droplets are coming together, they are having better gravity due to acceleration, uh, or due to the gravity force they are accumulating together, and they are getting big bubble and they are getting down. So it is as simple as that. So droplet condensation, another practical example I would like to elaborate, where on the roofs of the cars or on the seat covers you might observe in winter days, especially early in the morning, if you will observe droplets of the water, uh, which is also called as dew, or on the grass also you may observe. So such a kind of droplets are nothing but the droplet condensation. So friends, it is very essential to know these two type of condensation. First one is the droplet condensation, and another is film condensation. So uh, film and dropwise both are occurred, both may occur in heat exchangers. So basically, what is the criteria for formation of such a dropwise as well as the film condensation? So it is very clear when the surface is very clean, glossy, and non-dirty or regular, then in such a case film-wise condensation takes place. So at the controversy end, film-wise is nothing but a film is going to appear on the surface, which may increase the rate of resistance to the heat flow. So that again, it is difficult to impart the heat through that layer. So whenever the glossy surface is there, the surface is clean, surface is glossy, and dust free. In that case, the film condensation is taking place. Where at another end, droplet condensation is taking place whenever the surface is dirty, it is uh, having the dusty, dirty, and irregular surface, especially. In that case, a dropwise condensation is taking place. Now, many practices have been implemented, or it may implementing at the certain level. So basically, in our last chapter, we have been seen that a tube are generally made up of the stainless steel, so which is having the glossy, the chromium layer is there, which is very glossy, and thus such a glossy surface uh, always avails film condensation. So to enforcefully dropwise condensation may tried or occurred by using various sticky materials like wax, like oleic acid for some compound. So basically it is very essential to understand that whatever the condensate is not only one liquid, it may the it may be the mixture of the various kind of mixture liquids or solvents. So it is very difficult because condensation temperature, it is the temperature at which all drops or all solvent get condense, the phase transfer takes place from vapor to liquid. Obviously the surface should be less than the condensation temperature. The surface should be the temperature at which the condensation temperature is we are getting, it should be less than the condensation temperature. So basically whenever it is a mixture of two or more condensable vapors, then it again become very critical issue. Now friction losses in a condenser are normally very small because uh, the flow of fluid is very it is not the friction is not going to occur. So it is totally depending upon the pressures of the both streams, tube side as well as the shell side. So dropwise and filmwise, we have been discussed about the both cases, and I told you dropwise is expected or it is desirable, but uh, thumb rule says it is not possible to have dropwise condensation everywhere or all time. Now the designs are made up of by assuming there is a filmwise condensation. Additional resistance has been or it always taken considered while designing any kind of heat exchange equipment. So here the theory has been given. Now it is very essential that the film-wise condensation of water occurs on tube of the common metals if the both the stream and the tubes are clean, as I said earlier. Whereas the dropwise condensation is obtainable only when the cooling surface is not wetted by the liquid. This line is very important. Dropwise condensation is obtainable only when the cooling surface is not wetted by the liquid. If it is wetted, then undoubtedly filmwise condensation will be occurred. So in the condensation of steam, it is often induced by the contamination of the vapor with droplets of the oil. Now the quantity of the contaminant or promoter required to cause dropwise condensation is very minute. As I said, the wax, sticky material is used. Generally uh, mercaptant is which is a sulfur derivative is also or copper alloy is also used in case of effective or certain metals, whereas the oleic acids are also effective uh, in case of some metals like copper or brass, whereas the material like steel and aluminum are very difficult to treat to obtain dropwise condensation. Now many times the question has been asked in viva as well as in gate exam, what is the coefficient, average coefficient, which is obtained in pure dropwise condensation. So the answer is it may be as high as 115 115 kilowatt per meter square degree Celsius. So keep this fact in mind. Now coefficient for film wise or film type condensation is very also essential. See the basically the position of the heat exchanger equipment is probably defined or decided with respect to what are the space available at the plant. So we may find the heat exchangers are kept vertically in position. So the tube stack is vertical in such a cases. So generally generally what happens, vertical case is also